In this lesson, we're going to talk about header files. What I have here in VS Code is a simplified version of the program that we worked on in the previous video. On line 22, we print today's date, and then on line 25, we print tomorrow's date, and we do that by calling the tomorrow function. So let's just compile and run things to make sure that everything works and everything is fine. Now, in the previous video, it wasn't actually random that I placed the tomorrow function right here above main. So let's take a look at what would happen if we did things the other way around. So I'm gonna cut the function from there, and I'll paste it right here below the main method. And I'll save this, and I'll try to compile this, and things don't work. So what the compiler says is that on line 18, I see that you're trying to call the tomorrow function. However, I actually don't know what that is. So did we ever have this issue in Java? So here in IntelliJ, I have essentially the same program, and I do have the tomorrow function right here below the main method, and we do call the tomorrow function on line 9 from the main method. We can run this, and in Java, it's not an issue. So why is that? Well, the C++ compiler is a single pass compiler that works its way top to bottom in a linear chronological fashion. So by the time that it is on line 18, it hasn't seen the tomorrow function because the tomorrow function is on lines 21 through 28. So as far as the compiler is concerned, it doesn't exist, and everything crashes and you don't get a compiled program. Java compiler, on the other hand, is a multi-pass compiler, which would make many passes through the code until it would find the tomorrow function and things line up there. So how do we fix things in C++? Well, of course we could just go back to what we had, because that worked, and of course no issues there. However, this is not always going to be a good idea. Here I have some extra code that I'm going to copy and paste into our program, and it is just two silly functions, A and B. All they do is they decrement x to 0, but they do that by calling each other. So A calls B, and then B goes back to calling A. So I'm going to copy and paste the call to A, and I'll place that in the main method, and I'm going to save all this, and I will go back and try to compile. And of course we do get into the problem on line 17 that we don't know what B is, and that's right here. So then if we copy and paste B up above here, we are of course going to get into the issue that now we don't know what A is. And you can see this getting into a chicken and egg game pretty fast. So how do we fix this? So the way you fix this in C++ is that you have to split the implementation and declaration of functions into two parts. So to save the implementation, I'm going to copy the implementation of all the functions, and I'll just place it down here below the main method. Once you get this to work properly, it actually doesn't matter where the implementation goes. So I'll just label this as implementation. And then here is going to be part 1, which is the declaration. So how do we turn functions into just their declarations? Well, we delete the body and we replace that with a semicolon. So I'm going to do that for all the functions that I have here. And now we have the function declarations. So what's going to happen this time is that as the compiler works its way top to bottom, it's going to see the declarations and it's going to understand that those functions are coming up somewhere. It's going to be aware that those functions exist. And we don't have the bodies up here on lines 6 through 8, so we don't get into the issue of B trying to reference A and A trying to reference B. That does happen in the implementation. However, by this time, the compiler already knows about both A and B. So the technical term for this is forward declaration. You're forward declaring functions for a single pass compiler. So I can save this and I can go back to the shell. I can compile and beautiful, everything works. And I can do the same thing. I can run and everything is great. Okay. Once we start working with classes in the next video, you would see that in C++ you do have to forward declare your classes as well. As the size of the program grows, you can imagine that it can get quite annoying having to have all your declarations up here at the top of the code. Another issue is that what if we had multiple files that were looking for the same functions or classes? Where would we put the declarations in that case? So this is where header files come in. What the header files would do is they would store for you things such as the function declarations, the class declarations, and values of constants. So let's create a header file for this program. We'll make a new file and we'll save it. And the typical convention here is to give it the same name as is the name of your CPP file. And then the header file just has the .h extension. You can, of course, call your header file whatever you like, as long as you remember what it is, but this is a very widely used convention. What we're going to do next is we will now cut all the declarations from the CPP file, and we'll paste them into the header. We'll save the header, and all we need to do is we just need to now let the CPP file know where the declarations are. And we do that using an include statement. So we'll write include. However, since we are including a file that we created ourselves, we have to use double quotes instead of the angle brackets here. So we include first program.h. And then we save this, and we can compile and run, and everything is fine. So at this point, if we had other CPP files that were reliant on functions or classes defined in this header and implemented here, all we would need to do is just to throw in this include statement at the top of those files. But the way that we have things here now, that could lead to issues. In particular, it could cause the compiler to try to compile the header several times. And then the compiler would be trying to define functions which were already defined and get into things like name clashes. The way this is dealt with in C++ is by adding some very standard boilerplate code to the header. You don't need to be too concerned about it, but nevertheless you can watch me do it and I'll talk about it in broad terms so that you know it's there and you have a rough idea what it's for. Okay, so I'm in the header and I'm going to start adding this code that we need. So what it actually is a series of preprocessor directives, and preprocessor is the program that runs right before the compiler, and it sort of lays out all of the files for the compiler and tells the compiler what it needs to do with them. So what we have here now is that we have the name of this constant, and we're saying define the entire header to be this constant. And then we wrap that into an if statement. So it says that if you come into this header, and if this constant is not defined, so that's what if and def stands for, then go ahead and define it. And if it is already defined, then don't do anything. So we have the end if here. So, and the standard convention is to have the name of the constant match the name of the header file, all in caps, _h. But you can call it whatever you want as long as you're consistent. It is also my preference that the include statements are to be in the header. You don't have to do it, but it's something that I like to do. In this particular case, I would also have the using namespace line in the header as well, but that's not always a good idea, and we'll talk about that hopefully later on. We'll save this. I'll save this here. By the way, the include statements are also part of the preprocessor directives. Essentially, everything that starts with the # is preprocessor code. So now I'm just going to go ahead and compile this to make sure everything works. And things are fine. So to summarize, today we talked that in C++ you do have to forward declare your functions and classes in a header file. And this is the typical layout of the header file here. You have the preprocessor directives, and then you would put things like your import statements, definitions of constants, classes, and functions in there. And then you have to include the header file in each CPP file that depends on that header. Okay, thank you.